Hi guys, welcome to my channel. So in this tutorial, we'll be looking at the integral of x plus 1 all divided by x squared plus x minus 2. How do we evaluate this integral? It's the integral of a rational function. So how do you do that? So this integral of x plus 1 over x squared plus x minus 2 dx is equals to, I will just multiply the numerator by 2, but I can't just do that. I can't just multiply the numerator by 2. I have to divide by 2. So that will nullify the effect in the numerator. That is half times 2, that is 1. So the original equation is still the same. So if I multiply this numerator, the reason why I multiply the numerator, you see that shortly. So we have 1/2 the integral. Can now split this. This is 2x plus 2 all divided by x squared plus x minus 2 dx. Now here, the integral 2x plus 2, instead of 2, permit me to write it as 1 plus 1 all over x squared plus x minus 2 dx. And this one can be simplified as so. You can group the first two, 2x plus 1 aside all over x squared plus x plus minus 2 dx. Now what happens here? So let's split this into two integrals. 1/2 all multiplied by the first integral. First integral is 2x plus 1, the first one that we grouped, all over x squared plus x minus 2 dx, plus the integral of 1 all over x squared plus x minus 2 dx. Now the first integral is very easy, so let's call this one I1 and call this one I2. So let's tackle the I1. I1 is equals to the integral of 2x plus 1 all over x squared plus x minus 2 dx. This is a u sub, and this is just the natural logarithm of the denominator. Whenever you are integrating and you differentiate the denominator, and that is exactly what is in the numerator, then the final answer, or the answer for that integral, is just a natural logarithm of the denominator. So this is a very simple trick. So if I differentiate the denominator and I'm getting the numerator, the integral is the natural log of the denominator. So if I differentiate x squared plus x minus 2, I'm getting 2x plus 1. So in that case, the value of my integral is just going to be the natural logarithm of x squared plus x minus 2. But you can use the u sub. You can let u to be equal to x squared plus x minus 2. So you have du dx is equals to 2x plus 1. Du dx is 2x plus 1, and then you can have du is equals to 2x plus 1 all multiplied by dx. So it means wherever you see 2x plus 1 multiplied by dx, you can just replace with du. So I1 is equals to the integral of 1 over u times du, because this is du, which is from here, and this one is u, which is from here. So this is the natural logarithm of u, and what is u? U is x squared plus x minus 2. So that is the natural logarithm of x squared plus x minus 2. So that is the value of the first integral. That one is really very simple. Now the second one, that is where we have to do the work. So the second integral is the integral of 1 all over that. Let's do that in yellow. So I2 is equal to the integral of 1 over x squared plus x minus 2 dx. This one we have to complete the squares. So completing the squares, we look at the coefficient of x, which is 1. You take half of that. Half of 1 is half, and you square that. That's 1/4. So you add 1/4 to this expression. Add and subtract 1/4 to this expression. So that becomes x squared plus x minus 2 plus 1/4 minus 1/4. So when you do that and you group x squared plus x, you bring 1/4 and then minus 2 minus 1/4. That becomes, this expression becomes x plus half all to the squared minus 9/4. So this denominator can be expressed as this. That is by completing the squares. So my I2 becomes the integral of 1 all over. Instead of this, I write this. That is x plus 1/2 all squared minus 9/4 dx. That is by completing the squares. Now we can do u sub. Let u equal to x plus 1/2 du dx is equals to 1. In that case, du is equals to dx. So our integral, we can now take our integral from the x world into the u world. I2 is the integral of 1, 1 all over x plus half is u by squared minus 9/4 du. And we need to do another sub here. This is now a trig sub. So the subs are in layers. So we can let u be equal to, here, what squared will give you 9/4. The trick here is to take a number in which, if you are squaring that number should give you 9/4. So that is 3/2. So let u is equal to 3/2 secant theta. Then du d theta is equals to 3/2 secant theta tangent theta. That implies that du is equals to 3/2 secant theta tangent theta d theta, like that. So we can plug everything and take everything from the u world into the theta world. I2 is equals to the integral of 1 over u squared. U is 3/2 secant theta all squared minus 9/4 du. Du is 3/2 secant theta tangent theta d theta. What next? I2 is equals to the integral of 1 all over 3/2 squared is 9/4, which is now matching with our 9/4 here, can easily be factorized. So that is the trick behind the 3/2. So secant squared theta minus 9/4 times 3/2 secant theta tangent theta d theta. This is theta. So 3/2 is a constant, comes in front. 3/2, the integral of 1 all over 9/4 is factorized out. Then you have secant squared theta minus 1 d theta. This is still with secant theta tangent theta d theta. This is tangent. So this is 3/2. 1 over 9/4 is a constant, so that becomes like 4/9. It moves out of the integral sign. So 1 all over secant squared theta minus 1 is tangent squared theta times secant theta tangent theta d theta. This one simplified to be 2/3, the integral of tangent theta secant theta all over tangent squared theta d theta. And that simplifies to the 2/3 integral of secant theta over tangent theta. The tangent theta will cancel one of the tangent thetas in the denominator. That becomes 2/3 the integral secant theta is 1 over cosine theta times 1 over tangent theta, that is cotangent theta, and tangent theta is sine over cosine. So 1 over tangent theta is cosine theta over sine theta d theta. This was our I2, and I2. So our I2 is still 2 over 3, the integral. The cosine thetas will cancel, we are left with 1 over sine theta d theta. And what is 1 over sine theta? That is cosecant theta d theta. So the task now is to to integrate cosecant theta d theta. And if you know that the value of that is just a natural logarithm of cosecant theta minus cotangent theta, that is the integral of cosecant theta d theta. So now that we have our final integral, we can now take our answer from the theta world back into the u world using this. U is equals to 3 over 2 secant theta. We know that u is equals to 3 over 2 secant theta. So now how do you find this? We can multiply by 2, 2u over 3 is equals to secant theta. Now let's draw a right angle triangle. Put our right angle here, put our angle here theta. So this line is opposite to the angle theta, so that becomes the opposite. But secant theta, what is secant theta? Secant is hypotenuse over adjacent. Secant is hypotenuse over adjacent. So hypotenuse is always the line which is opposite to the right angle. So this is 2u. Adjacent is the line which is just adjacent to our angle, which is 3. So our task now is to find this opposite, which is the one opposite to our angle theta. We can use the Pythagorean theorem. So 2u squared, which is the square of the hypotenuse, is equals to the sum of squares of the other two sides. 3 squared plus, we really don't know the opposite, so we can just call that a question mark for now. This is 4u squared minus 9 is equals to this. And we can find our opposite side, which is the square root of 4u squared minus 9. So this one is 4u squared minus 9 in a square root. Now we are ready to find what cosecant theta is and what cotangent theta is. Let's do that in yellow. Now cosecant theta. Cosecant theta is equals to, cosecant is 1 over sine. Sine is opposite over hypotenuse. So cosecant is going to be hypotenuse over opposite. So hypotenuse is 2u. Opposite is square root of 4u squared minus 9. Now let's find cotangent. Cotangent theta. Cotangent is equals to 1 over tangent. Tangent is opposite over adjacent. In that case, cotangent is going to be adjacent over opposite. Adjacent is 3. And opposite is the square root of 4u squared minus 9. 4u squared minus 9. Now that we have our thetas in terms of u, we can plug them back into our the integral. So our I2 in terms of u is 2 over 3 natural logarithm of the absolute value of cosecant theta, which is 2u over the square root of 4u squared minus 9 minus cotangent theta. Cotangent theta is 3 all over the square root of 4u squared minus 9. This one can further be simplified as 2 over 3 natural logarithm of 2u minus 3 all over the square root of 4u squared minus 9. Now we have our integral I2 in terms of u. Now let's move from the u world back into the x world. What is x or u in terms of x? What was our substitution? We can go back here. Can't remember what it was. So u was equal to x plus 1/2. U was equal to x plus 1/2. So it means wherever you see u, you can just plug in x plus 1/2. So our I2 becomes 2/3 natural logarithm of 2 into x plus 1/2 minus 3 all over the square root of 4x plus 1/2 squared minus 9. And that's this can be simplified. I love simplification. This is 2x plus 1 minus 3, so that's 2x minus 2 in the numerator divided by this one can be written as 4. So the 4 can go in as 2 squared, which will multiply to have 2x plus 1 all squared minus 9. So that is how this one can be simplified. So this is the integral of I2 in terms of x. Now we can now find our original integral, which is the integral of x plus 1, what we are asked to find, over x squared plus x minus 2 dx. And that should be equal to what? That one was equal to I1 plus I2. That is from here, but multiplied by half. So in that case, we will have to take what I1 is and add that to the integral of I2 and you multiply by half. So I1 was the natural log of x squared plus x minus 2. So our integral is equals to I1 plus I2, which is multiplied by half. And half, the first integral was the natural log of x squared plus x minus 2 plus half multiplied by 2/3. That is the integral of I2, which is this one, the natural logarithm of 2x minus 2 all over the square root of 2x plus 1 squared minus 9. So we can now simplify things out, which is 1/2 natural logarithm of x squared plus x minus 2 plus 1/3 natural logarithm of 2x minus 2 all over the square root of 2x plus 1 squared minus 9 plus the constant of integration. So this is the integral of x plus 1 all over x squared plus x minus 2 dx. So this is the value of the integral. So if you know any a very simple method to solve this, please let me know in the comment section. I think this was very long. If you know of any trick or any idea that can solve this one faster, let me know in the comment section. Anyway, that's it. So if you like the video, make sure to subscribe to my channel for more content. Hit the notification bell so that when I upload, you get to watch it. Thank you so much for watching, and I'll see you in the next one. Bye bye.